Hi guys, welcome to my YouTube channel. Today I want to discuss the um, balancing of equations, and to do that I'm going to show you something a little bit inspiring, the language of chemistry, just like if I wrote down in English woods. It contains two oxygens or two O letters. That's the same case for SCO2. It contains two oxygens. In chemistry, we literally don't do COO. Sometimes in organic chemistry, we do show that to represent functionals, but in normal structural formulas, we just do a closed formula with the number of those letters uh, in that compound. Now, if I take one of these O's, what would just be meaningless. Just as I change this from 2 to any other number like CO3, it's meaningless. It's not a compound. Okay, so CO2 means this. Okay, it has two oxygens connected to the carbon, and that's the way we note this. So underscripts do really mean something about the identity. This is basically a compound. You can't change it unless you broke the bonds. So if I have methane and I have oxygens and two molecules of oxygens in a chemical reaction, it would produce one CO2 and two water molecules. Okay, this is how I write that down in chemistry. Let's just do that. CH4 plus O2, and it's two of it, giving me as one CO2 and two H2O. Okay, that's how I write that. Okay, so that is the meaning of the two, the coefficient. It just means the number. So that doesn't really mean anything other than a number. Okay, but these two means that they're connected together. So these are the identities. It gives the compound the definition of being an oxygen or being a CO2, for example. But these are just the sheer numbers. So 2H2O means just two molecules of water. Okay, that's the meaning of this. And with this, I want to move on to balancing equations. Okay, the way I just showed you, I just literally balanced it showing you that if methane burns, I need two molecules of oxygen, and it gives me just one CO2 and two molecules of water. These numbers, having to understand that for this reaction to be balanced, you need two oxygens, one CH4, so don't need any more, and CO2 just as one is going to be enough, and two of H2O. That is called balancing, and that is what I'm going to do today and show you how do I balance. Okay, and I'm going to show you, walk you through small simple examples, literally to harder and harder examples. Okay, let's just start with a very simple example of CO plus O2 and CO2. Now if I write down this, it doesn't mean I do know what is this number here. It literally means I don't know. So I can't tell if there's one carbon here or two oxygen because I don't know what this number is. What is the number? And the job is to find out. So we go for the compound that has the largest underscript and the most variety. The most variety of elements is carbon and oxygen. You could find it in both of these compounds. The biggest subscript is for this and this, so I go with this one. And I put literally one for that. I could change it later on if I hit a fraction or something that makes the work complex. But if I put one, it means now on this side I have one carbon and two oxygen, one times two and one times. If there's nothing, it means it's one. Okay, so the underscript 1 is the only thing that we don't write every time. If it's anything other than 1, we have to write it down. Like here it's C1O1, but we don't write it, we just say CO. And this is O2 and this is C1O2, so we just say CO2. Okay, so one carbon, two oxygen. And here on the other side, you have to make, you don't know what to put for oxygens because there are two of them and you don't know how these two oxygens are going to be spread out. But you have one carbon, so you put one carbon here, and that makes one oxygen here, 1 times 1, plus you don't know how many more you need to make two oxygens. So if you want to make two oxygens, you need one more, and to put one here, what x you put here to get 1, that should be a half. If you put a half times 2 is giving you 1, plus that 1, it gives you 2 oxygens. You could now change it to 2, 1, 2 with multiplying everything by 2. That is normal, that is alright, but you could also keep with the half if you don't want to do this. If you hit a fraction in a previous stage, this we hit it at the last stage, you are going to do the multiplication to be able to continue. Let's just do tons of examples so you could get the hang of it, as I do. C8H8 plus O2, oh my bad, giving you CO2 and H2O. Okay, so this is an example of combustion. For combustion there is a rule, and we could also use our own rule of going for the compound that has the most variety and largest underscript. Just like I showed you with this example of a CH4 and some oxygen, here that's the same story. I put a 1 for this, and then I look at my substances. I know it's 8 carbons here so far, and because I don't have any hydrogen, it's also going to be 8 hydrogens. I don't know this, I don't know this, I don't know this, so I can't judge. I know definitely I have 8 carbon and 8 hydrogen, so I could go to this and this with my carbon and hydrogen and judge them. How many CO2s would I need to make a 1 times what gives me 8? There should be 8 as well. For this one, what times 2 gives me 8? That's a 4. Okay, so it's 4 oxygens here, 8 times 2, 16 oxygens, so 20 total. And for 20, you have to do 20 divided by 2, or 10. 10 times 2 gives you 20 oxygens on this side as well. So 1, 10, 8, 4 is the coefficient. That's how you do a combustion. You start with your fuel, you take care of these two, then you go back to check for your oxygen. That's the way you do it. Let's just go do one more example. H3BCO plus H2O gives you H3BO3 plus CO. Oh my bad. Let's just write it down in a very smaller fashion. I apologize for the delay. I would try to make for it, but I have to do it in a one line so that you could, I hope you could all see that. Yes, that's good. So let's start with either this one or this one. This has a O1 and this has an O3, so I would start with this one. Though it doesn't have carbon, but it has boron in it, I could do 1B here. That means I don't know this and I don't know this, also I don't know this and I don't know this. Okay, so if I put 1 here, it means you can't judge hydrogens because you have some hydrogens here. You can't judge oxygens because you have some here in the CO. Okay, and also, oops, my bad. And also, 1 boron means you have to have 1 boron. So that's the only thing you could judge. Now from this, there's no other carbon in this molecule here, so there's 1 carbon. I could go back here and say, here I also need 1 carbon. Okay, now if you do that, then you could see that the number of oxygens is now determined here, because there's no oxygen here. I have 1 oxygen here, 3 oxygens here, that makes 4 oxygen, and 4 oxygen here. You have 1 already here, so you need 3 more here. Okay, so 3 H2Os to make 4 oxygens, and as you do so, you have all the coefficients, so you could count hydrogens in this part. Now 3 times 2, it's 6, plus 3, it's 9 hydrogens. And to make for the 9 hydrogen here, you have 3 already, and you need 6 more, so you do 3 times 2, which gives you 6. That's how you balance this reaction. Let's do yet another reaction. Let's do I2 plus Na2 S2O3 gives you NaI and Na2S4O6. Okay, so to balance this equation, you look either for this one or this one, and this one has 4 and 6, so it's better to start with this one doing a 1. Okay, and we don't know all this. So if I do 1 here, sodium is not determined, sulfur and oxygen are. If I have 4 sulfur here, then I could do 2 here to make 2 times 2 because it's 4 sulfurs. And I could do oxygens. Oxygen and hydrogen are the last thing I'm going to be interested to do. If I have metals, I should go like Na. If I can do my metals, I should go for them. If not, I go for the first available non-metal. Here, I cannot judge my sodium because I don't know what this compound, how many of these compounds I have, so I don't know 2 plus what, so I can't judge sodium, which is a metal. That's why I move to sulfur, and oxygen and hydrogen I'm going to move in them at the very last stage. So I have 2 here. When you do that, you are going to have definitely balanced out your also the amount of your oxygen here. 2 times 3, it's 6 oxygens, and on this you could see 1 times 6, it's also 6 oxygen. But you have also no sodium in this compound, so total sodium of 4 here. You have 2 already here. With 2 more over here, you could get to the total of 4 sodium on this part as well. Okay, so 4 sodiums each, and as you do so, you could see that the I are going to be 2 iodine here, and I have to have 1 here to make 1 I2, actually 1 times 2 to make 2 iodines for the reactant side as well. Let's do more examples. Let's do PCl3 and Cl2 giving you PCl5. Okay. Again, that's the deal. I don't know. So I'm going to judge between these two because they have the variety, and this one has larger coefficients. So if I put 1 here for this, I have the number of my phosphorus, it's 1, so I do 1 phosphorus here, and I have the number of chlorines, 5 chlorine, and also I have 3 chlorines here. So for this, if I just put 1, it's 2 more, and it gives me 5 chlorines as well. Okay, so that's balance in and of itself. Okay, so let's do one more example. KClO3 giving me Cl2 plus O2, and I'm going to judge what sort of numbers do I need as my coefficients. Again, these coefficients like O2, I do know that there is O2, but I don't know if there are 2 of them, 3 of them. I don't know the number, so that's what the coefficients mean. I go for this one, has the variety and the largest coefficients ever. 1 here, K is, oh my bad, let's see, this is KCl. Let me just fix that real quick. I apologize for the lag in time. 1 potassium, so I go 1 potassium, that's the metal. 1 chlorine, also 1 chlorine, and 1 O3, so I have to go 3 halves. Because that's the last one, I could actually ignore that and move on, or if I wish to, I could do 2, 2, and 3. Okay, that would also make it. Okay, so that is this. Let's do more examples. It's another combustion equation, and I'm eager to do that real quick. CO2. Remember, for any combustion reactions, you're going to have a fuel, something gives you some CO2, you use some O2 for burning, and add some H2O. Okay, the thing is to find out how many of those, and we do 1 for our fuel that makes 1 carbon and 10 hydrogen, my bad, 4 carbon and 10 hydrogen For the 4 carbon, I put a 4 here for my CO2, and for the 10 hydrogen, I make 5H2, which gives me 10 hydrogen as well. Then I have 5 oxygens here, plus 4 times 2, 8. So 13 oxygen, 13 divided by 2, or else I could just say I multiply everything by 2 to get 2, 13, 8, and 10. That's this. I could move on to this example, Li2CO3 plus CaCl2 giving you LiCl, and let me just write it down one more time. Li2CO3 plus calcium chloride giving you LiCl plus calcium carbonate. Okay, and I'm going to do this. So which one I do I start with? I start with this one. I have the variety and I have the largest coefficients. Okay, so if I put 1 here, 2 lithiums means that's the metal. I start with that, 2 lithiums here. Okay, and I do know that there's no carbon here, so 1 carbon, and I should do 1 carbon over here as well. And if it's 1 calcium, then that's a metal. Of course, I go with the metal first. I didn't go for with the calcium after lithium because I couldn't. I don't know what was those coefficients. But as soon as I do take care of carbon, which is 1 carbon here, I can find out that calcium is also 1, and that's 1 calcium. Now I have 2 chlorines. That's the 2 chlorines, and oh, now I have the ion equation being balanced. Okay, so let's move on to more examples. Actually, this is going to be my last example. Hopefully, if I could do it as fast. Mercury nitrate, Na2S, mercury sulfide, and sodium nitrate. So this is my equation. Remember, if you have something that is a polyatomic anion, this is something like this, like CO2. And because it's an anion, this is a neutral molecule, but this is an anion, so you need some nitrite in this compound, 2 of them. So you do a parenthesis, okay? That's how you show it. We will have more of these complicated examples as we move on. So let's do this one. We'll do one for this because of the variety and the number of elements. It's 1 mercury, so 1 mercury here. It's 2 nitrogen, so 2 nitrogens here. 2 sodiums, so 1 here. That's balanced. Sulfur is also balanced. And oxygens, there's 6 oxygens here also. 1 times 3 times 2, it's also 6 oxygens. So I want to wrap it up here for this video.